Hello everyone, welcome back to episode 5 of our high level system design playlist. And in this video we will take a look at API strategy, that is selecting between REST, GraphQL or gRPC. So with this API we will basically see that how we can choose the right API for scale and for good developer experience. And this video is a continuation of our YouTube playlist. So in case you have not watched our previous videos, please watch it, and let's start with this. So as we were saying in our application CodeShare, right, we had designed our APIs and we had seen the API first thinking model, and now we will proceed forward. So before we decide on the API strategy for CodeShare, I would like to share a story that perfectly illustrates why this choice even matters, and why this is a very important step in our high level system design. Okay, so we will talk about Shopify and the API evolution of Shopify. So it's 2015 and Shopify is growing fast, but their REST API is becoming a bottleneck, right? Developers are making a lot of API calls just to render a single product page, and mobile apps are struggling with overfetching. Third-party integrations are breaking constantly. Okay, then Shopify makes a very important decision, and they move to GraphQL. Okay, they commit to migrating their entire API ecosystem from REST to GraphQL, not just adding GraphQL as an option, making it their primary API strategy. Okay, and 3 years and massive engineering investment later, the results speak for themselves. Developer adoption has skyrocketed, and mobile app performance has improved a lot, and third-party integrations have become more stable. Okay, but here's the question that we need to answer today in our perspective. Okay, so this strategic decision of GraphQL for a commerce for an e-commerce backend makes sense, but does it make sense for our system, that is CodeShare? And that is what Alex, our architect, is trying to implement here. Okay, so would the same decision make sense for CodeShare? That is what we are discussing. So we are building a system that needs to handle 100 million requests per day, right? As we discussed last time. And CodeShare has 15 plus client types, and it's running at a global scale. And we want to provide a developer first experience. Okay, so we have mobile apps, we have web front ends, we have CLI tools, IDE plugins, and third-party integrations, each with different needs, constraints, and different performance requirement. Okay, so today I'm going to show you the systematic decision making process, okay, that we can follow, and that can determine which API paradigm serves for our users the best, and which each with different needs, different constraints, and different performance requirements. So let's dive into it. And today we will see that we are not choosing based on what's trending with, okay, and we are choosing based on what works for us, what works for our use case. So we have the three API paradigms here. Okay, so one is REST, another one, second is GraphQL, and the third is gRPC. These are the three most common core types of API interactions that you will encounter in backend system. And yeah, let me introduce to all these three and show you why each exists by looking at real companies that bet their businesses on each approach. Okay, first one is REST. Stripe, a very well-known payment processing company, chose REST and built a billion-dollar business on it. Why? Look at their domain. They have payments, customers, subscriptions. All these are clear, well-defined resources with predictable operations, right? So that means the operations that we perform on these resources, the CRUD operations, they have a proper structure. Okay, and naturally the HTTP verbs like get, post, put, all these fit into it naturally. Okay, and using REST also provides a very important feature, that is excellent caching support. So while building REST API based backend, we can build excellent caching mechanism that can help to make the requests fast, right? It's predictable, cacheable, and any developer can understand it in seconds. Stripe's API documentation is legendary precisely because REST makes it intuitive. Okay, coming to GraphQL, right? So GitHub's problem was different, right? GitHub faced a different problem. Developers needed complex data relationships, okay, repositories with contributors, pull requests, with reviews, issues, with labels. For every request, developers had to make 15 REST API calls to render a single page. Okay, and when the number of API calls are so much segregated and so much sort of branched, that's where GraphQL makes a lot of sense. Basically, with GraphQL, we have a single endpoint, and one request can exactly provide us the data that we need. GitHub's GraphQL API serves over 1 billion requests per day because it solves the right problem: complex data relationships with flexible querying. Okay, at Google, the situation was a little different. Google's internal services make trillions of calls per day. Okay, they need microsecond latency, strong typing, and bidirectional streaming. Okay, so the HTTP 1.1 protocol, okay, with JSON simply wasn't fast enough for this requirement. Protocol buffers serialize 5 to 10x faster than JSON. That is what forms the base of gRPC. Binary protocol reduces bandwidth, and the code generation ensures type safety across 12 programming language. So that is a great achievement there. And when Google search uses your protocol for internal communication, you know it works at scale. So that's the advantage of using gRPC. Okay, look at these numbers. Performance characteristic, right? REST 2 millisecond latency, excellent caching. GraphQL 5 millisecond latency, poor caching but flexible queries. gRPC sub millisecond latency, perfect for high throughput system. But here's the critical insight: the best APIs isn't about just performance numbers though. It is about matching the paradigm with your specific constraints and user needs. Okay, so we'll now take a look at a decision framework that an architect generally follows, and let me show you the decision framework that I use systematically to evaluate API paradigms. This matrix has guided architectural decisions at great engineering teams, and now we will follow the same for CodeShare. Okay, so this is a basic systematic decision making framework that considers 6 factors: client diversity, data patterns, performance requirements, and team capabilities. And also it takes into account the learning curve and the complexity of the queries. Okay, and this matrix guides architectural choices at scale. First factor is client diversity. This means how many different types of clients need to integrate. As you can see, REST wins here. Every programming language, every platform, every tool understands HTTP and JSON. GraphQL requires specialized clients, right? gRPC needs code generation and isn't web browser friendly. Second factor is caching. This means, can you leverage HTTP caching infrastructure? This is again where REST dominates. GET requests are cacheable by browsers, CDNs, and proxies automatically. GraphQL queries are typically post requests, which are much harder to cache. gRPC is again a binary protocol. Traditional HTTP caches can't help you here as they are not valid in this architecture. The third factor is performance. This means, what are your latency and throughput requirements? gRPC wins for raw performance here as it offers sub millisecond latency, binary serialization, HTTP 2.0 multiplexing, and streaming support. But GraphQL can be faster for complex queries by eliminating round trips. Okay, REST sits in the middle in this criteria. It offers good performance, especially with caching. When we talk about learning curve, we mean how quickly can our team and ecosystem adopt to it. REST has the lowest learning curve. Any developer who's worked with web API understands it. GraphQL requires learning new concepts, for example, resolver, schema, query optimization, etc. gRPC requires understanding of protobuffer or protocol buffer mechanism and code generation. The next factor we have is tooling ecosystem. So the tooling ecosystem for REST is quite mature, and for GraphQL and gRPC it is growing and it's pretty limited. Okay, Performance of REST in case of complex queries is noted to be poor, and that's where GraphQL excels by reducing the round trips, and gRPC is good in this aspect. Let's apply this framework to our CodeShare, and let's see how we can decide on a particular API paradigm for our app. So if we do a client analysis of CodeShare, we see that we have to support mobile apps because users will be using our CodeShare platform from mobile apps. We have to support a web front end. We have to support CLI tools as well, okay, and we have to support integrations with, let's say, IDE plugin or third-party app, or provide webhook support, okay. So mobile apps need simple CRUD operations, offline support, and battery efficiency. When we talk about web front ends, they want a dynamic UI and real-time updates. CLI tools need fast operations and minimal dependencies, and third-party integrations need predictable APIs and extensible documentation. Okay, this diversity is very crucial. When you have 15 plus different client types, you need the lowest common denominator that everyone can adopt successfully. Okay, so what will be our decision process? Let me walk you through our systematic analysis of CodeShare requirements, and this is how you make architecture decisions based on data and not opinions. So first we will clarify the diversity assessment. We have 4 mobile apps across iOS and Android, and 3 web interfaces. Main app, let's say we have a main app, we have an admin panel, and we have a public viewer. We also have CLI tools for developers, and we have IDE plugins for 8 plus editors. Let's say we are having tie-ups with IntelliJ, Eclipse, and others. Okay, we also have webhook integrations. We have third-party API consumers as well who have integrated with our system. This level of diversity strongly favors REST. We can't force every IDE plugin developer to learn GraphQL or to implement gRPC, correct? So this first step hints towards REST API. Now we move to step 2. This level of so in step 2, CodeShare operations are fundamentally simple. They are basic CRUD, okay, and we are not building a social media with complex social graphs. We are not building GitHub with intricate repository relationships, correct? Simple data patterns don't need complex query languages. REST's resource model was maps perfectly to our domain in this case. Let's move on to step 3, that is performance requirement. 100 million requests per day sounds quite impressive, but let's break it down. High read to write ratio hints that it is perfect for HTTP caching, okay, as the read request is high. So as we have to integrate with CDN for global distribution, CDNs always love REST, okay, and sub 100 millisecond response time achievable with proper REST design. So this third step, that is performance requirement, again hints us towards REST API. Fourth point is developer experience priority. Okay, so this is where CodeShare's business model becomes critical. We need third-party developers to integrate easily. Okay, our design and our documentation must be self-explanatory. Onboarding friction must be minimal. Again, REST documentation is intuitive. We have the open API specs that we discussed, which generate client SDKs automatically. Every developer platform from Postman to Insomnia to Curl supports REST natively. So this is a no-brainer. That step 4 points us to REST. Now we move to step 5, that is team and ecosystem constraints. This is a very important factor to consider while choosing an API mechanism. Our team has deep REST expertise. That's what CodeShare business stakeholders say. Our infrastructure is HTTP optimized, and the monitoring tools understand HTTP semantics as well. Our security practices are also built around HTTP headers and status code. Technical depth isn't just about code, it's about the team knowledge as well. So infrastructure investment and ecosystem alignment is needed at this point. But as far as this case is concerned, our team is hinting towards an implementation of the REST mechanism. So now we see, of course, it might be clear for you, the final verdict for CodeShare is that we will go ahead with the implementation of REST API, not because GraphQL or gRPC are inferior, but because REST optimally serves our specific constraints. That is, we have to support a diverse client base. Okay, we have very simple data patterns, not something very complex or very nested. Okay, and we have our caching requirements that is best served by REST, and because of the ecosystem alignment that we are seeing. Okay, so REST wins here because of the three factors: performance, adoption, and simplicity of our use case. Now we'll see the implementation strategy and the evolution path for us. Now let's talk about how we will implement this decision intelligently. So we don't just choose technologies, we also plan for the evolution path, how the technology we have chosen now will evolve further in the future. Okay, so we start with the RESTful resource modeling. Okay, because we have to set up a REST foundation now, and we have to go with consistent URL patterns and proper HTTP status codes, handling error and exception handling, comprehensive API specifications, because again documentation is our product, and we implement a multi-layer caching and a robust rate limiting from day one. So this phase 1 forms the REST foundation of our system. Okay, then the phase 2, we go for an enhanced experience. So first 6 months we build this foundation and we solidify it up. Second, after 6 months we take up the phase 2 where we enhance the experience. We don't stay with REST forever. As our business grows and our requirements change, we also adopt accordingly. Okay, in 6+ months, when we have more complex query needs, we can always add a GraphQL layer on top of our REST foundation. We are not replacing REST, we are augmenting it for specific use cases. You can have a look at this timeline. Okay, so look at this timeline wherein, let's say in Q1 of 2024, we implement a REST API v1 for foundation and scale. In Q3 2024, we get the requirements and we implement a GraphQL layer also for complex queries. In Q1 of 2025, we implement gRPC for internal microservice communication when we require sub millisecond latency for our internal API calls. That's when our system reaches a huge scale. Okay, so this isn't about choosing one technology forever. It's about choosing the right foundation and evolving strategically as needs changed. Okay, so here's what our REST API will look like now. As we discussed, we will design these APIs like this with proper HTTP resource naming and proper usage of the HTTP verbs, clean resource based URLs, consistent response formats, okay, and proper HTTP semantics. Notice how every URL is predictable, it's understood. If you understand one endpoint, you will guess the output and you will also understand the rest of it, and that's how the REST APIs behave. Okay, so when do we consider a GraphQL layer, right? When clients need complex queries like fetching pastes with user details and comments in one request, like when you have to make multiple joins and the querying becomes quite complex, that is when we go for GraphQL. When mobile apps need specific field subsets to reduce bandwidth, to reduce the up and down network travel times and latency, when we need to add real-time features like let's say live code collaboration, okay, that is the time when we consider adding a GraphQL layer on our REST API foundation. Okay, so let's see the key architectural principles that we learned in this episode. Basically, we don't have to choose just one paradigm. Instagram uses REST for most operations and GraphQL for complex feed related queries. Netflix uses REST for client APIs and gRPC for internal services. So remember that these principles basically say that choose APIs based on the client needs and not technology trends. Okay, REST is going for simplicity and caching. GraphQL is going for complex queries. gRPC is going for performance. So what we should take away as a summary from this episode is start simple and evolve strategically. Right? The Shopify story that I started with, they succeeded not because they used GraphQL or GraphQL is inherently better than REST, but because GraphQL solved their specific problem, that is complex e-commerce data relationships. For CodeShare, REST currently solves our specific problems, that is client diversity, global caching, and developer adoption. We are not following the trends, we are making the right architectural choice for our business. So that is what should drive your API decision. And yeah, let's build an API that serves our users for the next decade and evolve it as well. So this was it from my side for this episode. I hope that I made good use of your time, and thanks a lot for watching the video. And please provide me feedback of how you're liking this series and these episodes, what's going good and what's not going good, so that I can improve further. So thank you for your time again, and we'll see you in the next episode. Bye bye.